Hi, this is Mr. Bruss, and I decided I want to do a quick video talking about linear programming, mostly because we have a test tomorrow, and one of the test problems will be very much like this problem right here. We're looking at employment cost with supervisors versus workers, and so we'll go ahead and we'll jump right into the problem. So Peter's Pizza Shop, it specializes in many different types of pizzas. The shop hires workers and supervisors. The workers are paid $500 every week. I'm going to write that down. And the supervisors are paid $800 every week. Now, workers can make 40 pizzas and 40 batches of breadsticks every week. Supervisors can make 50 pizzas and 80 batches of breadsticks every week. Peter's Pizza Shop needs at least 200 pizzas and 240 batches of breadsticks made every week. So it looks like our restraints or constraints. How many workers and supervisors should be hired to meet the constraints, but also minimize the employment cost? So we have a certain quota. We need to make 200 pizzas every week and 240 batches of breadsticks every week. But in doing that, we want to minimize the employment. And that's our first question. What are we trying to minimize? We're trying to minimize employment cost. And the question is, number two, how can we represent employment cost? So I'm just going to say cost. Well, that's going to be equal to the amount of money we're paying the workers plus the amount of money we're paying the supervisors. Now it says the workers are paid $500 every week. The supervisors are paid $800 every week. So if we want to create an equation, we want to use these two variables, x and y. And it looks like we're going to call x, they're the number of workers that we have. We're going to call y the number of supervisors. So we want to minimize the employment cost. Well, we know the workers are paid $500. So it's $500 per worker plus $800 per supervisor. So I guess this would be our answer to number 2 right here. Write an equation that will represent the employment cost. It's $500 per worker plus $800 per supervisor. And we're going to use this later when we want to find out what the employment cost is once we get some other data. Now, the third question is, what are some constraints that we have? And this is probably the hardest part of the problem. When I think of constraints, I think of limits, or what do I have to do? And looking at this, we have a lot of information. But the word that kind of jumps out at me is this right here. We need at least 20 pizzas, and it looks like at least 240 batches of breadsticks. These are our constraints right here. We need at least 200 pizzas. So I'm going to say my constraints. We need at least, so 200 pizzas. At least means we need greater than or equal to 200 pizzas. We need at least 240 breadsticks. This is where I'd start with constraints. Look for those words like at least, or if you see a word that says no more than or something like that. We need at least 200 pizzas and at least 240 breadsticks. So the question is, how many workers plus how many supervisors is going to tell us how much pizza we have, and then how many workers plus how many supervisors will tell us how many breadsticks we have. So this is kind of helpful because we know x is the amount of workers, and we know y is the amount of supervisors. It's easy to kind of set this up like this first and now go back and fill in the equation. So we label this pizza, so everything up here is talking about the amount of pizzas made, and everything down here is talking about the amount of breadsticks made. So we need at least 200 pizzas made. So the question is, how much pizza can a worker make in a week? Well, here's my information about workers. It looks like workers can make 40 pizzas. So we know that 40 pizzas per worker will go in this equation because workers can make 40. And it looks like supervisors can make 50 pizzas. So remember, x is workers, y is supervisors. This is going to be our top equation. 40x plus 50y has to go over 200. if X is the amount of workers and Y is the amount of supervisors. Looking back at this, we want to know how many breadsticks a worker makes and how many breadsticks a supervisor makes. Well, it says a worker makes 40 and the supervisor makes, looks like, 80. So fill it out without the numbers first and then go back and make sure you label over here so we know that 40 and 50 are talking about pizzas and pizzas. Now, so we're talking about our constraints. We started out with this side. We know we need more than 200 pizzas and more than 240. Then we went back and filled in this equation. Now what we want to do is we want to graph this equation. And to graph it, we're going to graph these by finding the x and y intercepts of each equation. So I'm going to find the x, this equation, and the x. To find the x-intercept, I would cover up y. So if I'm finding the x-intercept of this orange equation, I'd cover up y and just do 200 divided by the number in front of x. So 200 divided by 40. I believe that should give me 5, but I'm going to double check because I don't want to mess up. X is going to be 5 because 200 divided by my x, 40, is 5. 200, if I want to find the y-intercept, I cover up x. 200 divided by 50 is 4. So to graph this line, I just know I'm going to have to graph where x is 5 and y is 4. On this equation, looks like if we want to find our x-intercept, 240 by 40 is 6, and 240 divided by 80 is 3. So now with these x and y intercepts of each equation, I can go ahead and graph these. Now, it looks like I don't really have a scale, and I'll have to create one real quick. My largest number is 6. So as long as I go from 0 to 6 somewhere in this scale, and then both scales have to be the same for the x and y axis. As long as I go from 0 to 6, I should be okay. So I think what I'm going to do is, let's see. I'm going to do every 2 boxes is going to be 1. So this would be 1, 2, 3, 4, 5, 6. And every 2 boxes is going to be 1. This helps spread it out a little bit. I know my x-axis is the amount of workers I have. My y-axis is going to be the amount of supervisors. If I were to graph that, come up with a title, it would be workers versus supervisors. Okay. So I chose my scale based off of making sure I can cover all these x-intercepts. I always have to start at 0. I have to make sure it's the same scale on the x and y axis. We know that the x intercept for this orange equation is 5. So I put a dot at 5 on the x-axis. And on the y-axis, the y-intercept is 4. So I could quickly graph this line just by knowing those 2 intercepts. It looks like we're going from here to here. And then the question is, do I shade above or below this line? Because this is an inequality. And actually, because of the word says at least, we need more than 200 pizzas. We need to actually shade above. This is a greater than or equal to sign. So we would be shading way above here. If I want to graph the green line, my x-intercept is 6. My y-intercept is 3. So I want to go ahead and graph between these 2 lines right here. And it also is above, so this one would also look like this. Now notice there's a little bit of a region where it's just green and a little bit of a region where it's just orange. When we want to talk about a problem that meets both of these constraints, we want to look at the area that's actually always above both lines, the area that's both green and orange. So the green part is not part of our area because it's below the orange line. And this part, this orange area, is not above the green line, so we won't count it. So the region we're talking about is a region that's above both lines. So to satisfy both these constraints, we have to always be above these 2 lines. So the next part that we want to look at is we want to test 3 of these bottom points that bound this region. That includes both. So from here to here is above both lines. From here to here is above both lines. Now those 3 points, looks like this one's going to be 0, 4. This one right here is going to be about 6, 0. And this one, I'm going to estimate that to be about 3 and 1.5, which makes this interesting because I don't know what it looks like to have 1.5 supervisors, but for the sake of the problem, we'll kind of keep going on. We have those 3 points, and we want to find out all these points kind of meet these constraints. We want to see how many workers and how many supervisors do we hire to minimize the employment cost. So this point means 0 workers, 4 supervisors. This point means 6 workers, 0 supervisors. And this point technically means 3 workers, and I guess you would say 1.5 supervisors. Although that's not a realistic problem, we'll have to look at it. Maybe the supervisor can work half the time or something for that week. So to find how much money each of these workers and supervisors would cost, we're going to plug that back into our employment cost. Our employment cost is 500x plus 800y. So we want to plug all these points back into this equation right here, 500x plus 800y. So if I plug in 0 workers and 8 supervisors, it would look like this. If I plug in 6 workers plus no supervisors, which I wonder what no supervisors would look like, I plug in a 0 there. Because I'm plugging in, that's my x coordinate, that's my y coordinate, and I'm just kind of substituting those in for their proper variables. And here, if I want to plug in 3 workers plus 1.5 supervisors, I would plug that in. I could go in and type this in my calculator. If I type this in, I could literally just type in for the first one, 500 parentheses 0, which I know is going to be 0, plus 800 parentheses 4. That means that the employment cost for this one is going to be 3,200, or 3,200. 3,200. If I want to plug in, if I hit second enter, I can retype my equation. If I want to plug in 6 workers and 0 supervisors, assuming that no supervisors, nothing's burned down or anything like that, I'll go ahead and hit enter. We're looking at a cost of $3,000 if it's all workers. If I plug in 3 workers and 1.5 supervisors, we should get $2,700. Now remember, we want to minimize the cost while still meeting these constraints. So looking at these, 0 workers, 4 supervisors will cost $3,200. 6 workers and 0 supervisors cost $3,000. But our minimum cost of 3 workers and I guess 1.5 supervisors would be $2,700. So to kind of answer our problem, to minimize our cost, we would minimize the cost at $2,700 if we hire 3 workers, because that's my X, and 1.5. And that's going to be our answer to this problem. Now I'm not going to go over the writing part, although I will post it on the notes, so you'll still be able to see what my final written response will look like. But all the math for this problem is done right here. Like I said, the test problem will look just like this. Just make sure we know what our X and Y means. X is workers, Y is supervisors. And we minimize our employment cost with 3 workers and 1.5 supervisors.